Hello, everyone. Greetings of the day. The authors and invited guests welcome you to this technical session, session 8E, myself Prashi, and the session will be moderated by me. On behalf of Global Knowledge Research Foundation and GIA Scholastics, it is my great pleasure to welcome you to the 11th International Conference on Information and Communication Technology for Intelligent System ICTIS 2026, Bangkok, Thailand. The 11th edition of this conference is being organized in a hybrid mode. The physical event will be held tomorrow in Bangkok, Thailand, and the virtual event is being held through Zoom from 9th to 11th of April 2026. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we will have 10 presentations, and each presenter will be given 10 minutes for their presentation and 2 minutes for the question and answers. On the 9th minute, I will be raising a gentle reminder. There is another request to all our participants that you stay connected to us till the closing remarks. If you have any queries or any updates, you can write it to me in the chat box given down below. Before we start our session today, I would like to introduce you all to the chair of our session, Dr. Lokendra Singh Umrao. Dr. Lokendra Singh Umrao is Associate Professor, Department of Computer Science and Engineering, Madan Mohan Malviya University of Technology, Gorakhpur, India. With over 11 years of teaching experience, his specializations lies in algorithms and high-performance computing. His research interests include blockchain technology, Internet of Things, big data analysis, and parallel computing, contributing significantly to advancements in these domains. We welcome you to the session, sir. Before we start, would you like to say a few words to our participants?
Yeah, please proceed.
Okay, sir. Thank you so much. By sir's command, we'll start our session. And like to call upon our first presenter for this session. Our first presenter for the session is Mohammed Kaif, presenting a paper on the title Autonomous AI Agents for Offensive Cybersecurity Capabilities, Ethics, and Defense Implications. I request you to kindly start with your presentation, please.
Hello, good morning, good afternoon, everybody. Please allow me to share my screen.
Yes, sir.
Okay, is my screen visible?
Yes, sir, your screen is visible now.
Okay. My name is Mohammed Kaif. I'm a student who is in my final year of undergraduate studies at SRM Institute of Science and Technology, India. Today, I will be presenting our project titled Autonomous AI Agents for Offensive Cybersecurity, Capabilities, Ethics, and Defense Implications. My team consists of Anshika Rohit Ashade, and Sashi Mehrotra. Moving to the project overview, the background of our project focuses on how cybersecurity is moving from reactive defense to proactive vulnerability detection. Artificial intelligence can simulate cyber attacks to identify system weaknesses effectively. Furthermore, autonomous AI agents can perform penetration testing faster than manual methods. So the real world problem we are addressing is that manual penetration testing is very time consuming and requires skilled professionals. Consequently, many vulnerabilities remain undetected until exploited by attackers. So organizations clearly need automated systems to improve security assessment. Our motivation for this work is to improve the speed and efficiency of vulnerability detection. We also aim to reduce dependence on manual penetration testing. Finally, we want to explore the capabilities of AI-driven cybersecurity systems. This places our application domain within cybersecurity, ethical hacking, penetration testing, and AI-based security automation. To formally define our problem statement, traditional penetration testing requires significant manual effort and deep cybersecurity expertise, which makes the process time-consuming and resource-intensive. So there are several automated security tools. Many of them still rely on predefined exploits or require continuous human guidance during the testing. So this heavily limits their ability to fully automate the vulnerability detection process. And the importance of solving this problem is increasing as cyber attacks continue to grow in frequency and in sophistication. Organizations are facing serious risks such as financial losses, data breaches, and system disruptions when vulnerabilities are undetected. Therefore, faster and more intelligent methods for identifying security weaknesses are absolutely necessary, and the existing solutions have several limitations. So many tools operate with a man in the loop approach, meaning they cannot function independently. And reinforcement learning based tools often depend on known exploits and struggle to adapt to newer vulnerabilities. Traditional vulnerability scanners also lack the advanced reasoning capabilities, which makes it very difficult for them to analyze complex attack scenarios. The main goal of this project is to design and evaluate an autonomous AI-based penetration testing agent, which is capable of identifying and exploiting vulnerabilities in vulnerable systems. The objectives also include developing an AI agent for automated vulnerability detection, implementing a structured verify, exploit, confirm testing cycle, and we also aim to integrate security tools such as Nmap, Nikto, and Metasploit, which are widely used in the industry. Additionally, we will also be comparing our system's performance with tools like Pentest GPT, Deep Exploit, and OWASP, ZAP, which are commonly used in the industry. The expected outcome is a system that improves the speed and efficiency of penetration testing while demonstrating the potential and limitations of autonomous AI agents in offensive cybersecurity. Our literature review spans several key studies to establish a foundation for our work, such as a 2019 study on deep exploit demonstrated that AI can automate large portions of penetration testing workflows using the deep reinforcement learning integrated with Metasploit. We have also reviewed a Pentest GPT 2023 study, which shows how large language models like GPT-4 can enhance security testing, even though they still require some human supervision. And another 2024 paper, which highlights the growing capability of autonomous AI agents in offensive cybersecurity and is based on Reaper AI. And we also noted the 2025 Vulnbot framework, which showed the potential for collaborative AI agents to simulate human like red team operations. Finally, 2025 comparative evaluation indicated that while AI agents perform well on routine tasks, they struggle with complex reasoning, making hybrid human AI approaches currently very effective. Let us talk about the existing system. The current penetration testing systems, they are including automated vulnerability scanners and AI-assisted security tools. And the tools that we mentioned, such as Pentest, GPT, Deep Exploit, and OWASP ZAP, are widely used to identify vulnerabilities in applications and network systems. These tools help security professionals perform reconnaissance, scanning, and vulnerability analysis. Some tools rely on predefined exploits, while others struggle with complex attack scenarios or multi-step reasoning, limiting their ability to perform complete end-to-end penetration testing independently. So our proposed system is to overcome these barriers, which we have discussed. We are presenting our proposed system. The proposed system introduces Bastion AI, an autonomous AI-driven penetration testing agent designed to automatically identify and exploit vulnerabilities in target systems. The agent uses a large language model as its reasoning engine to analyze scanning results, generate attack strategies, and execute penetration testing steps without continuous human intervention. A key innovation that we did is the standard structured verify, exploit, confirm cycle to ensure that the vulnerabilities are properly validated before exploitation. And it also integrates external security tools like we discussed, Nmap, Nikto for web analysis, and Metasploit for exploitation. Compared to existing tools, the proposed system provides greater automation and faster vulnerability discovery while reducing the need for human guidance. And it also enables more intelligent decision making during penetration testing by combining reasoning with traditional security tools. So let us have a look at the system architecture. The main component is the Bastion AI agent, which is coordinating the penetration testing process and integrating the reasoning engine with the security tools. We are utilizing a GPT-4 LLM as the reasoning engine to analyze scan results and generating attack strategies and deciding the next steps. A Python orchestrator is serving as the task planner and state manager, which controls the workflow and connects the LLM with external security tools. The data flow begins with the orchestrator initiating reconnaissance using tools like Nmap and Nikto. The scan results are then sent to the GPT-4 reasoning engine, which analyzes context to determine vulnerabilities. The orchestrator then executes Metasploit to attempt exploitation. Everything operates against target environments like DVWA, Metasploitable2, and OWASP Juice Shop. This system follows a verify to exploit to confirm process to validate vulnerabilities before logging findings into the vulnerability report. Now, let us talk about the methodology. The proposed system follows a structured penetration testing methodology implemented through the Bastion AI agent. It begins with reconnaissance and scanning, where tools such as Nmap and Nikto are collecting information about open ports, services, and potential vulnerabilities. This collected data is then analyzed by the GPT-4 reasoning engine to generate possible attack hypotheses and determine suitable exploitation strategies. And after the identification of potential vulnerabilities, the system attempts exploitation using tools such as Metasploit. Each detected vulnerabilities goes through a verify to exploit to confirm cycle to ensure it is real before reporting. Finally, the system generates a vulnerability report containing detected weaknesses, successful exploits, and testing logs. The tools and technologies that we are using for the powering the project is GPT-4 large language model and Python. For security tools, Nmap is performing the network reconnaissance. Nikto is detecting the web server vulnerabilities and Metasploitable executes the exploitation. And all of these experiments are virtually controlled and safely conducted in a VMware ESXi system. The test environments simulate vulnerable systems, including DVWA, which stands for Damn Vulnerable Web Application, Metasploitable2, and OWASP Juice Shop. These tools are widely used for penetration testing learning and for research. Next is the modules implemented. We have successfully implemented 5 main modules. The first is the reconnaissance and scanning module, which performs the initial information gathering using Nmap and Nikto. The AI reasoning module uses GPT-4 LLM to analyze scan results, identify vulnerabilities, and to determine the next steps. The exploitation module executes controlled exploits attempts based on AI-generated plans using Metasploit. And the verification module implements the verify to exploit to confirm cycle. The reporting module collects findings and generates a vulnerability report.
Excuse me, sir. I'm sorry to interrupt you. However, we have crossed our 9-minute mark. I request you to kindly conclude as soon as possible.
Yeah, I'll conclude in a minute. Okay. So our experimental results are highly encouraging, and we have tracked metrics such as vulnerabilities found, exploitation success rate, time to exploit, false positives, etc. Bastion AI has detected 8 vulnerabilities in DBWA, which outperforms traditional scanners like OWASP ZAP. In Metasploitable2, we followed a similar pattern, in which the system was able to exploit 12 vulnerabilities. In OWASP Shop, the agent has detected 15 vulnerabilities, and overall the system achieved an 88% exploitation success rate with only 1 false positive. So performance, you can see that Bastion AI performed way faster than Pentest GPT and DeepExpert in several scenarios, although human-guided systems still achieve slightly higher coverage in complex vulnerabilities. Let us quickly talk about the results. Key observations confirm that the Bastion AI successfully identified and exploited several vulnerabilities. The autonomous AI agent reduced the time required for vulnerability discovery compared to some existing tools. While Bastion AI performed faster than reinforcement learning tools like DeepExploit, human-guided systems such as Pentest GPT, still they showed better coverage for complex vulnerabilities. During the project, we encountered multiple challenges like integrating the GPT-4 reasoning engine with tools such as Nmap and Nikto and Metasploit, because it required very careful orchestration. And managing communication between the Python orchestrator, AI agent, and scanning tools while maintaining a stable workflow was very challenging. The AI agent needed to maintain context across multiple texting steps and sometimes struggled. So we had to give it the more context. Differentiating between real vulnerabilities and normal system also led to many false positives. So in conclusion, this research demonstrates the potential of autonomous AI agents in offensive cybersecurity through the Bastion AI system. The agent successfully automated reconnaissance, vulnerability detection, exploitation, and reporting. However, limitations remain, including challenges with complex reasoning and occasional false positives. The most effective approach that we found is a hybrid model where AI has assisted human And this actually improves the speed and coverage while maintaining oversight. And these final slides are including the references and academic papers that supported this research. Yeah, that's it. Thank you for your time and consideration. We welcome any questions you may have about our project.
Thank you. I would like our session chair. Sir, do we have any questions for sir?
Yeah. Uh, what new what new defensive strategies or technologies should organizations adopt to effectively detect
I think your voice is breaking.
and mitigate
So I'm not able to hear the question well.
Just a second, there might be some technical error. Dr. Singh. Looks like sir is rejoining. We'll just wait for 1 second. So, Sir Kaif, I thank you for your presentation. I guess there is some network issue on our session chair's part. So I would like to call upon our next presenter. Meanwhile, our session chair joins us. Our next presenter, I would like to call upon Arpita Dey, presenting a paper on the title Backtracking Free Autonomous Navigation in GPS Denied Environment. Ma'am, we welcome you to kindly take over with your presentation.
Hello, I am audible to everyone.
Yes, ma'am.
Okay, I'm just sharing the screen. Is it visible to you, please?
Yes, ma'am. Your screen and the PPT is visible, ma'am.
Okay. Should I start now?
Yes, please.
Okay. Myself, Orpita Dey from West Bengal, India. I have already completed my PhD from Jadavpur University, India. Today, I am going to present my paper, which is Backtracking Free Autonomous Navigation in GPS Denied Environment under the guidance of my supervisor, Professor Buddhadev Shah. This is the overview of our paper. First, I will introduce you the basics of path planning and following, and then I will highlight some limitations of the predefined path. Then I will discuss about the motivation of our model, and then the model description, including some important definitions, the loop compute move cycle, and finally our problem statement. After that, I will discuss in detail the technique using which the robot plan the path and follow it to reach to the destination successfully within finite time. Now, the first thing is what is the meaning of path planning and following. Path planning is basically a computational process through which the robot can determine the path, an optimal collision-free path from the starting point to the destination during its journey to the destination. I have highlighted some different drawbacks of the predefined paths. If the path is damaged or affected by some natural disaster or some outside object, then path may be lost and hence the robot also get lost. Another thing is if the path is defined by some access points in the network and any change happens in the network, then we need to redefine the path and gradually the robot may get lost or it have to think in a different way. So it will enhance the energy of the total system. So these are not encouraged. So in our model, we have prepared our model in that way so the robot will design the path and follow it. The next important thing, what we have done with the work in a GPS denied environment, because GPS is the most easy way to navigate the robot we know, but in certain situations like battlefield, indoor or outdoor operational fields, GPS is not also available. It may be hacked or get jammed. So the security reasons are highlighted, and GPS is also very costly. So efficient path planning and following in a GPS denied environment is the challenge of our work. And the most important thing what we have done, that is the backtracking free path planning and following, because backtracking wastes time, energy, and computational resources, whereas backtracking free path ensures efficient path planning to move directly toward the destination. This is the motivation of our model, where the robot plans the path using only local information from the access point in its vicinity. Non-use of GPS make our technique cost-effective. With comparison to the different literature survey, we have proposed this method as low cost as well as it works properly in absence of adequate light. Our method takes care of unsafe zones in the network, which are known as holes in the network. In unsafe areas, that is network with holes, and specifically the network with convex holes, our method can provide the shortest path toward the destination. Otherwise, it will definitely ensure the guaranteed reach of the mobile robot within finite time. This is the difference of the look, compute, move model, what we have used in our work in comparison with the existing look, compute, move model. In our method, in look phase, the robot searches available access points. In compute method, with this help of the position of those access points, the robot designs its path for next movement. And it move phase, the robot move to the next location, either directly along a straight line or with continuous monitoring. This is our model, where F is the field of interest. It contains some access point APs, and the range disk of the APs of constant radius R are here designed as the circles. Here the holes are H1, H2, H3, the white regions, which are interior holes as well as convex holes, and only one outsider or exterior hole is HE. We have defined some different notations and definitions through our model. The range disk of the access points, their boundaries, two access points or APs are adjacent if their range disk intersects. These are another definitions, which are covered fields. The fields, every point of which is inside the range disk of at least. And holes are the maximum open connected region in F, where no point of the region falls inside the range disk of any AP. Here the picture shows the whole boundary, which is the blue line, and the graph, the whole bounding graph is the red colored graph, whose vertices are the whole bounding APs. Now the important thing is what are available, what does it mean for available AP for a robot? If the robot is at some current position P and that point P belongs to the radius of some APA, then we say that A is the available AP at P. This is the picturization of the whole bounding graph, which is definitely a cycle. Here is the look, compute, move cycle. In look phase, the robot senses all its available AP and find out their positions. In compute phase, the robot taking the positions of those available AP and the distance between the current position and destination, the robot determines the nature of its movement. And in move phase, either the robot moves directly along straight line or with continuous monitoring when the robot appears at a point which is located on the whole boundary. Our problem is basically, suppose the robot is initially situated at a point I belongs to FC and its destination is the point D, which is also in FC. Then the robot requires to construct a path P in such a manner that where every point on P lies in FC from I to D, and following this path, the robot can reach to D successfully. So the goal of our problem is to design a path connecting the initial and destination point, planning the path and following it to reach to the destination within finite time. The most interesting thing is during our process, the robot does not enter into any hole and the existing holes in the network are convex, and the robot never repeats any subpath, or the robot not enter in an infinite loop. Chirality is the thing. Chirality is needed when the robot initiates some computation sitting at the hole boundary, and during the traversal at the hole boundary, the robot will move in such a manner that it will covers the hole boundary, keeping the hole at its lip, that is in the anti-clockwise manner. I will define the picture later. This is the technique at a glance. The robot is never directed to enter inside any hole. If the destination point is within the range disk of any AP, the robot directly moves to D. Otherwise, move along the straight line, joining the current position and D until the robot reaches at a point on BH for some voltage. Arriving at any point at BH, the robot cannot move along the straight line. Then the robot further move along, traversing along the BH. And while traversing along the BH, it continuously checks availabilities for new APs. On entering in the range disk of new AP, the robot repeats the same loop compute move model. While following this step, there is a chance for falling in an infinite loop, which is depicted in this picture. Here, the path P starting from P1, P2, P3, then P5, and again at P4, the robot falls in an infinite loop and traversing along to P4, P5, P5, P4, and in this way. So this is the challenge of in our problem, then how we will overcome it. This is our path planning algorithm, which will overcome this problem. Here, all the phases, that is the loop, compute, move phases, are defined step by step. And these are in some definition which we have designed for following this, designing this path, which is halt off and lobot. The important two lemmas here: if C be the current position of the robot at any moment and D doesn't lie inside the range disk of any available AP at C, then if halt C is equal to C and C belongs to some hole boundary BH, then there must exist a point on BH along CD such that all the point of CM except C and M lies in the hole. There is another lemma: each point on the hole boundary BH of a hole H lies within the range disk of exactly one AP or two APs, not more than that. This is the direction of the hole boundary traversal for the robot for an interior convex hole, which I have said earlier, that in the anti-clockwise manner.
Sorry to disturb you, ma'am. However, we have completed our 9-minute mark. I request you to kindly conclude in them. Yeah.
Okay. This is our detailed algorithm for the compute phase. And this is the algorithm for move phase. We have proved the correctness of our algorithm also. These are the proofs. Now, just a simple example for our proposed technique. Suppose the robot is at a point, current position C, and the available APs at this position are A1, A2, A3. Then the robot first starts the look phase, which communicates all the APs A1, A2, A3 and find out their positions. With this position, robot computes its next position, which is the halt point being at C, and it is N, that is the next position. Then the robot moves along the straight line CD and halts at N, and then design the path in its further steps. This is the one type of cases. And other type of cases is traversing along the hole boundary in the next picture, in which the robot is at current position C and it is on BH, so the robot cannot move along CD because other points on CD lies in the hole. Then the robot starts traversing along the boundary and it get the next AP as front AP, which is A2 at the point, arriving at the point P. Then it continues its process and arrive at C1. From C1, the robot strategically exit the whole boundary because the distance of CD and C1D, when the robot compares the two distance, C1D is definitely less than CD. So from C1, the robot strategically exits the whole boundary and starts its next traversal along the straight line and reaches to D finitely within finite time. So the basic two important things of our proposed technique is either the robot reaches to the destination within finite time following the shortest path, and if not the shortest path, then the guaranteed reach of the robot to the destination is designed. So this is the contribution at a glance. A backtracking free technique is designed in a GPS denied environment. The robot avoids the network-wide communication along APIs, which greatly reduces the energy dissipation. It successfully finds a path to reach the given destination using only local information. The robot designed the path using only constant memory. If the path is fully covered, then the robot reaches
Arpita,
to D following the. Sorry, sir.
I have one question.
Sir, please.
How scalable is your solution when deployed in large or complex environments, such as
Sir,
underground mines, disaster zones?
Sir, that is why we use the GPS denied environment. What are you highlighting? Please repeat me. Sir, can I get you?
No.
Sir, please repeat your question.
How scalable is your solution when deployed in large or complex environments, such as underground mines or disaster zones?
Okay, sir, we have randomly deployed the APIs we can deploy the APIs randomly in those areas, and as it is a GPS free technique, so we can deploy them at anywhere and deploy the robot which can successfully do its job after reaching to the destination.
Yeah.
There is no.
Okay.
Okay. Okay, sir. Thank you so much.
Thank you so much for your presentation, ma'am. Thank
Thank
you.
you. Thank you.
Now, we'd like to call upon our next presenter for this session. Our next presenter is Elena Rosheva, presenting a paper on the title Brand Crisis on Social Media, Opinion Accumulation and Automation of Crisis Analytics. I request you to kindly take over with your presentation, please.
Yeah, hello everyone. I will just share my presentation. 1 second. I hope you can see my presentation.
Yes, we can see the presentation.
Okay, great. So, dear colleagues, I'm glad to present our research called Brand Crisis on Social Media, Opinion Accumulation and Automation of Crisis Analytics. As we all know, many brands from time to time find themselves in rapidly developing crisis situations on social media, and these situations might cause huge reputational damage and sometimes even the collapse of the company or personal brand or political leaders collapse depending on the type of the brand. And to prevent these crisis situations, they should be managed. And there are not so many academic studies that would explore the crisis experience of brands relying on advanced methodologies and taking the crisis discussion nature into account. The crisis discussion nature is very important to understand what exactly brands need to do to resolve the situation. And we have conducted the literature review and studied some organizational models of crisis communication and crisis management, and we came to the conclusion that all of the models do not take the discussion nature into consideration. So we have decided to employ our own methodology and our own theoretical framework to analyze crisis situations on social media. So we use the theoretical framework of cumulative deliberation, which was created and developed by my co-author Svetlana Bodrunova. This concept emphasizes the non-deliberative nature of modern discussions in mediatized environments. And according to cumulative deliberation concept, only a small percentage of substantial, meaningful discussion of alternatives within the framework of a public problem is observed on the web, which means the user's speech in public discussions is mostly non-dialogical. It is often aggressive and just meaningless. And most importantly, it's usually not consensus oriented, which means users are not really interested in solving the issue. They just want to express their opinion, and that might be the huge risk for the companies as their audience might just leave a huge number of negative comments, which later can cause a huge reputational damage, and it will be very hard to solve the issue. So the research questions that we have for this part of our research are presented on this slide. So the first one is what is the general dynamics of the discussion before, during, and after the crisis. The second is crisis discussion primarily cumulative or deliberative, and what are the parameters for automated analysis of crisis communication on social media. So to conduct this study, we chose one case of Russian in Russian environment. This situation happened a couple of years ago. It is about a so-called naked party. It was organized by a Russian TV presenter and blogger Anastasia Ivleeva, the girl you can see on the slide. She invited a bunch of Russian celebrities to her party in Moscow with an almost naked dress code. And let's say this is the most innocent picture of that event that can be presented here. Many people were really not wearing almost any clothes, and there were many posts and videos of that party published on social media by the celebrities themselves. So at the time of the party, they thought it was a very good idea, but later on, the society was highly offended by this event, and many people thought it was an inappropriate behavior for celebrities, especially at a time of war, and many people suffering at the moment, and they thought this was a very huge, it was a huge mistake to make such a party. Lots of celebrities had huge reputational damage, and the party host Anastasia Ivleeva faced many contracts, cancellations, and she was cancelled everywhere, and she was no longer a TV presenter, let's say, and her reputation was completely ruined, and it's not restored yet a few years after the incident. And that's how this minor situation, as it was seen at the beginning, turned out to her. And the second person you can see in this picture is Philip Kirkorov. He is also a very famous Russian singer. And as he is very famous, of course, the audience was shocked by his appearance at the party, and he was claiming he picked the wrong door, which became a meme. And he tried to apologize, but lots of his concerts were also canceled. But as he was very famous for a long time, and he probably had a very good PR team. He managed to restore his reputation, and now he's doing okay. But anyways, it was a huge shock for him as well. So to analyze this case, we created our own methodology. We created our own web crawler that helps to collect and automatically analyze data from social media. And we decided to analyze the data from two accounts of Anastasia Ivleeva and Philip Kirkorov on Russian social media platform ВКонтакте, which is the most famous platform in Russia where users can leave comments. So basically, it is like Facebook, but not Facebook. And we collected all the posts and comments that were posted in the 2 months window around the crisis period of time. And here you can see how many comments we collected. It was above 3,000 for Anastasia Ivleeva and above 12,000 comments for Philip Kirkorov. And later we automatically conducted the sentiment analysis and presented our visualizations in different forms so we can study the crisis dynamics and structure and create our automatic parameters for crisis communication analysis. So here is the result of our discussion dynamics analysis. So the first picture is about the Anastasia Ivleeva's crisis dynamics. There were not so many comments. I think she probably deleted, removed most of the negative comments, but you can see the sharp rise in the number of comments during the crisis. And contrary to expectations, the sentiment proportions remain similar to the pre-crisis ones, which was interesting for us because we thought that crisis usually is accompanied by the huge number of negative comments, but there were also neutral and positive ones, which is probably a sign of polarization.
Sorry to disturb you, ma'am. However, we have crossed the 9-minute mark. I request you to kindly conclude as soon as possible. Thank you.
Yeah, of course. Thank you.
Alina, I have one question. How does your system differentiate between genuine user sentiment and coordinated fake camping, bots, or manipulated narratives?
Sorry, could you please repeat your question?
How does your system differentiate between genuine user sentiment and coordinated fake campaign boards or manipulated narratives?
Yeah, so at the moment it's not seen yet, but we are trying to create our own tool for further crisis management analytics. And right now it's not very different from other tools, but what we are doing next will probably answer the question. So I will just show you the next slide very quickly. So we have revisualized the graphs that we see in the previous slides, and it depicts the crisis structure, the crisis discussion structure in both accounts of two celebrities. So here we collected all posts and comments that were posted during the crisis epicenter. So the cumulative part is the comments going up. So it is the comments without any meaningful discussion that are addressed to either to the brand or celebrity and not to other commenters. And there are only small there are very few and short threads of discussions under the posts. So that is a sign of the crisis cumulative nature. There is no dialogicity, and the problem is the brands itself were not trying to participate in the discussion and develop it so they could decrease the degree of negativity and try to change the narrative that was created by the crisis situation. So there are only a few chains of micro dialogues, and we see a potential in micro dialogicity. So we think that brands should use micro dialogicity to promote their positions. And basically, if we see a discussion structure like this, very vertical, that means the brand is doing nothing to resolve the crisis situation. Yeah. Sorry. Okay. So yeah, and I'm sorry. This is last slide. And based on our attempt to visualize the crisis discussion and our future research plan, we suggest the following list of parameters that might be further used for the automated crisis communication analysis on social media. So there are some quantitative and qualitative parameters, which are the flow intensity, the speed of propagation, reach and engagement, and sentiment and theme. So we are planning to further conduct the theme modeling analysis and deeper study the crisis cases on social media. So thank you very much for your attention. That's
Thank you
it.
so much. Thank you so much, ma'am, for your presentation. And as sir has already asked his questions, sir, do we have any furthermore questions from your info, ma'am?
No.
No. Thank you so much, ma'am, for your presentation. Now I would like to call upon our next presenter for this session. Our next presenter is Padma Lakshmi Govindrajan, presenting a paper on the title Design and Development of a Multimodal AI Framework for Real-Time Nutrient Deficiency Detection and Fertilizer Recommendation in Sugarcane Farming. I request you to kindly take over, ma'am.
Thank you, ma'am. Is my screen visible, ma'am?
No, ma'am. As of yet, you have not shared.
Is it fine now?
Yeah, just a second. Yes, now it is fine, ma'am.
Thank you very much for the opportunity. So myself, Dr. Padma Lakshmi. So I'm from Vellore Institute of Technology from India. So I'm here to discuss about the design and development of. Ma'am, is the slides are visible?
Yes, ma'am, the slide is visible.
Okay, sorry, okay.
Yes.
So design and development of a multimodal AI framework for real-time nutrient deficiency detection and fertilizer recommendation in sugarcane farming. So before starting up this topic, so I would like to inform you why I have chosen chosen sugarcane crop. So sugarcane, it is Ma'am, is the slides are visible?
Ma'am, the slide is visible right now. We can see the introduction,
But I could
sugarcane.
not,
Yes.
just a minute, ma'am, I could not see anything. Just a minute, please.
Okay.
Yeah. So, in India, sugarcane is considered as the most important commercial crop as it contributes to around 1.15% of nation's GDP and 10% of the country's agricultural gross domestic product. However, it occupies only 2.5% of gross cropped area. So, according to USDA, that is United States Department of Agriculture, India holds second position in sugarcane production next to Brazil. So during the current statistics, as per the current statistics, India has contributed to nearly 15% of the world's gross sugarcane production. So it is around 1.88 billion tonnes during 2024-25, while Brazil dominated to around 24% of its production. So the productivity, the average productivity of sugarcane in our country is calculated to be around 78 to 83 tonnes per hectare. Being a commercial crop and which has a greater demand in the world market, both domestic as well as in the world market, so the productivity of the sugarcane can further be improved by early detection and identification of nutritional deficiencies and the application of recommended dosage of fertilizers at every growth stages of the crop. As of now, the current soil assessment techniques are hampered by cumbersome wired architectures and slow processing times, leading to accelerated soil depletion. So by deploying an IoT-based system for real-time nutrient tracking, the farmers can able to optimize the fertilizer application by reducing the environmental impact through minimized leaching while maintaining high crop yields. The rationale behind the study is the main thing is to address there is a need for a system to identify the abnormality symptoms in the crop and to detect the nutrient status in the soil, followed by alerting the farmer about the nutrition deficiency and supplying proper fertilizers at appropriate root zones. So for this, agricultural drones will be employed for collecting the field level data. After it has been collected, an accuracy check can be done with the data simultaneously collected from the array of NPK sensors implemented in the region detected to have nutritional deficiency. So this is mainly done because it is necessary for us to identify whether the crop is really affected due to the nutritional deficiency or is there any symptoms of pest or disease infestations. So we are planning for both the drones to capture the images as well as the soil sensors simultaneously to know exactly what kind of deficiency has occurred. So it gives a supportive, authenticated estimation of the nutrients, which will immediately be communicated through a wireless network module. So the proposed study will help the farmers and other stakeholders to use the need-based and recommended dosage of fertilizers in a phased manner in order to maintain the soil health and minimize the fertilizer costs without sacrificing the yield. The hypothesis of the study is early detection and identification of nutritional deficiency using an array of implanted soil sensors which may improve the fertility status of the soil and helps in increasing the crop growth and improving the crop growth and yield. And providing timely recommendation of fertilizers using IoT-based alerting systems, which may reduce the crop deficiency, thereby increasing the yield. The key questions for this study is, so whether any imaging systems can help in detecting the plant abnormality symptoms, mainly the nutritional deficiencies. So how come the implemented sensors, mainly the soil sensors, will detect the nutritional deficiency? And what will be the accuracy of fertilizer recommendation in sugarcane crop from the images of leaves and stems? How can the proposed system be made cheap, viable, and reliable for the farmers? So the objective behind the study is to detect the plant abnormality symptom using imaging systems in the proposed sugarcane field, then identification of nutritional deficiency status using an array of implanted soil sensors, and recommendation of fertilizers using IoT-based alerting system. Then AI prediction about the soil quality for fertilizer recommendation during the crop growth stages, that is the overall stages of the crop. Then to create awareness about the farmers for efficient and sustainable nutrient management using technology-assisted cultivation. So we have gone through several references, and we found that there are so many traditional as well as the modern practices are being followed. But we felt that some basic technology for soil sensors are existing, but still it is more cumbersome with more wired networks, and it is again a time-consuming evaluation method. So our study addresses these deficiencies by integrating or developing an integrated AI and IoT-based system designed to provide real-time site-specific nutrient management. So the expected outcome of the proposed study is to develop an integrated system to identify the abnormality symptoms of the crop and to detect the nutrient status of the soil through IoT-enabled wireless sensor devices. Then to alert the farmers about the nutrient deficiency and to fertilize with appropriate nutrients near to the root zone through drip irrigation using fertigation tanks. AI-enabled prediction to recommend the fertilizers during the crop growth stages. So the proposed methodology is, so we are proposed to, the work is carried out as a sequence of data acquisition, then processing of data, then intelligent analysis, that is forecasting about the nutrient deficiency, and automated actuation stages integrating IoT, AI, and precision fertigation. So the framework is as follows. So we will be collecting data. So both the NPK data as well as the moisture level data from the soil as well as through the drones. Then data pre-processing, that is sensor data cleaning and the calibration, then image pre-processing. Then we go with AI analysis and fusion with the help of CNN abnormality detection to detect the nutrient deficiency, and also GRU and LSTM forecasting to forecast about the nutrient requirements. Then last step is fertilizer recommendation and control. So this is the layout. So the crop abnormality model detection. So for this we use UV images are being used are being analyzed using a transferred learning CNN to locate the visible deficiency symptoms and determine its severity. So next LSTM and GRU. So these models are used to forecast the impending nutrient deficiencies, significant soil parameters, that is NPK, mainly the NPK, then moisture, pH, EC, and temperature to monitor it continuously. Then we have come up with a platform that is the data and information from the network, sensor networks, images, and environmental context are then integrated through a fusion architecture to produce a nutrient deficiency label, severity score, and confidence measure. So to ensure the interpretability and agronomic safety, predictions are incorporated with crop growth stage specific nutrient gap model that convert the deficiencies into dosages of fertilizers with alerts given on high risk conditions and optionally permission fertigation control. So the major contribution here is simultaneous use of imaging system and implantable sensors to improve the accuracy of the nutritional deficiency, and an artificial intelligence aided system to predict the soil quality for fertilizer recommendation during the crop growth stages. So finally, the major discussion is visible stress symptoms in the crops are detected through the drone images that will be collected from the drone images, and the nutrient levels and other important parameters are monitored continuously with the soil sensors. So using time-based prediction models, the system was also able to preempt the potential nutrient depletion before it gets severe. In order to make sure that the recommendations are safe and easy to apply, the AI predictions are linked to a growth state-specific nutrient requirement model. So the proposed system allows proactive, data-driven nutrient management, which mitigates the risk of over-fertilization and supports scalable precision agriculture. The future scope of the study, so what we are planned to do in the future is, so the model will be validated using real-time data, and field level validation of the results will be conducted. So additionally, experimental results will be made using images captured using different illumination conditions and altitudes of the drone flight to evaluate the effect of these parameters on detection performance. So appropriate pre-processing and normalization techniques will also be explored in order to increase the robustness of the model under different environmental conditions. So with this, I wish to conclude with few points. So the work proposes a practical and intelligent system which would help the farmers to mitigate the nutrient deficiencies of sugarcane during every stages of the crop growth. So the approach combines drone imagery, soil sensor data, forecasting models, and agronomic guidelines in a comprehensive AI-based decision support system. So overall, the system will facilitate the proactive and data-driven nutrient management, assisting in reducing the nutrient application, enabling sustainable agricultural practices, and to offer a scalable digital solution to enhance the productivity of crop. So these are the references which I have referred for carrying out this work. So thank you for your time.
Thank you so much, ma'am. I
Uh,
would like to request, yes, sir. Any
How
question?
does your system determine the optimal type of quantity of fertilizer?
Sir,
And
actually,
does it
basically, we have some recommended blanket dosage of fertilizers, generally for each and every crop. So since we use the soil sensors, so it will detect how much is the nutrient status of the soil. So with those two, calculation will be made automatically, and it will help in suggesting or recommending the appropriate dosage of fertilizers.
does it account for long-term soil health and sustainability?
Yes, sir, because we are concentrating mainly for drip irrigation, like fertigation, wherein it is going to deal with the precision-based agricultural farming. So this is going to minimize the overfull application of fertilizers by the farmers, and the need-based, need-based application of fertilizers alone will be done based on the nutritional status. Am I audible?
Yes, ma'am, you're audible. Sir, any follow-up questions?
No, proceed. Next one.
Thank you. Thank you, ma'am, for your
Thank you,
presentation.
sir. Thank you, ma'am.
And I would like to call upon our next presenter for this session. Our next presenter is Mohammed Surya Nukara, presenting a paper on the title Detecting High Latency, Low Resource Anomalies in Kubernetes Microservices based on Application Log and Infrastructure Matrix. I request you to kindly take over with your presentation, please.
Oh.
Sir. So, Mohammed, can you hear me?
Hello?
Yes, yes.
Wait me for a second to.
For sure. Is there any difficulties on your end? Sir Muhammad?
I'm sorry for my bad connection.
Okay.
Here in my place is raining.
Okay, sir. If you want, I can show your presentation while you can narrate it. If that is the case, you can send the PPT to me if you're unable to
Wait.
present it. Okay.
If you can see.
Yes, yes, sir. We can see the presentation.
So, good morning, good evening for everyone, sir. My name is Muhammad Nugraha. I'm from Telkom University, Bandung, Indonesia. My paper present was detecting high latency resource anomalies in Kubernetes microservice based on application log and event metric. So in my project overview is my motivation in this project is increasing complexity in Kubernetes microservice that in today now is doing traditional monitoring and it failed to capture application level issues. So the goal of this project is to detecting high latency and resource anomalies and to improve reliability of system monitoring. Introduction is uh, today in modern application getting evolved from monolithic to microservices and Kubernetes become the most usage tool for orchestrating microservices. Uh, um, I'm sorry. Why this Kubernetes become one of the most used tool for orchestrating is its feature such as auto-scaling and self-healing, but this mechanism primarily rely on infrastructure level metrics such as CPU and memory utilization. So the main problem is that infrastructure metrics do not always reflect real application performance. As a result, performance degradation can occur without being detected, leading to potential service issues. And my case study is to better understand is conducted case study on a core segregation system in my university. So user experiences failure such as the course list not loading or being unable to complete the registration process. And this is interesting because during this failure, infrastructure metrics was shown as operating normally. So this is was a mismatch between system metric and actual user experience. Maybe this not maybe this is this condition uh, is what we define as the observability gap, where the infrastructure appears healthy, but the application is actually failing. This makes monitoring fragmented and difficult to analyze across multiple tools. So to address this issue, we propose an AIOps based framework that combines application log and infrastructure metrics. This approach enable more comprehensive monitoring and for anomaly detection. So how does it work? Is the system work by collecting application log and interface metric, then pushing both data sources into a unified data set. This data is analyzed using machine learning models to classify system conditions into normal, warning, or critical states. To generate heuristic data, we simulate traffic using Grafana K6. This including scenarios such as login, course selection, and registration. This simulation follows a 5-hour active pace and a recovery pace to mimic real world condition. And then for the simulation, we have a data preprocessing tool. So the data collected undergoes the several processing stages, including noise reduction, temporal position, and SLO-based labeling. This process transforms raw logs and metrics into structured data suitable for machine learning. We evaluate machine learning models, several, including decision tree, random forest, nearest neighbor, and logistic regression, and like GBM. To improve model performance, we apply hyperparameter optimization. This is to make sure that each model is tuned to achieve optimal result. So this is the parameter and range of value that is set. And for the result is show that 3 model achieve perfect performance at 100% accuracy. But for after evaluating model using further metric such as precision, recall, F1 score, and accuracy, we perform deeper analysis using the confusion metric to examine class level performance. This allows to identify how well the model distinguishes between normal, warning, and critical states, and to detect any misclassification pattern. This step is crucial to ensure that the model is not only achieving high accuracy, but also reliable to detecting critical anomalies, particularly silent failures in real-world environment. So among them, random forest demonstrate the most stable and consistent result. As you can see here, random forest has no zero mistake for the conversion metric. This confirms that our approach effectively detects silent failure. So in conclusion, we successfully detect high latency, low resource anomalies using an AIOps-based approach. This approach bridges the observability gap in modern Kubernetes system and improves the reliability of application monitoring. And for future work, we plan to integrate root cause analysis using distributed tracing tools and explore your unsupervised learning method to detect previously unseen anomaly pattern. So thank you for your attention. I will uh, I will also like to thank everyone for being here today, and I will be happy to answer any question, sir. Thank you.
Thank you so much for your presentation. So do we have any questions?
No more questions. Next one, please.
Okay, sir.
Maybe I will stop here. Thank you. Thank you, sir.
Thank you so much, sir.
Miss.
Thank you for presentation. Now I would like to call upon our next presenter. Our next presenter is Y. Ramadevi, presenting a paper on the title, His Views a Linear Time Hierarchical State Space Fusion for Histopathologic classification. I request you to kindly take over with your presentation, please. Ms. Rama Devi, ma'am, if you're here or anybody on behalf of her is here, I request you to kindly take over with your presentation, please. All right. So as we don't have anybody on behalf of ma'am or herself present, I would like to call upon our next presenter for this session. Our next presenter is Siddharth Shah, presenting a paper entitled Lapis Whale, a framework for continual learning in transformers through selective memory replay. I request you to kindly take over with your presentation, please.
Ma'am, is my
Yes,
sound
sir.
valid?
Yes, we can hear you, sir, clearly.
Sure. Ma'am, my screen is visible.
Yes, sir. Your screen is visible. We can see the people.
Yes. So starting with the topic or domain is AI ML and the category is deep learning. We have thought about the topic deep learning because of one of the major problems in deep learning, which is catastrophic forgetting. We'll first start with the introduction of transformers. Transformers are a great development in AI ML industry from the last 10 years, 5 to 10 years, because uh, earlier the models used to train the sequences one by one, like RNN recurrent neural networks used each of the part of the data one by one, step by step, and they train them one by one. Transformers was a huge leap because they don't train it one by one, because that there is two problem in them. One is speed; it takes much time to load, and the second is context. The model trained forgets the distant words. So transformers took a big leap in that, because they train all of it parallelly at one go. This is called multi-head attention, wherein they take all of the parts of the training data and they train it at once, and this gets repeated again and again. So transformers is a good thing indeed, but there is one more problem which comes in this, which is static data. When we train using transformers, the data which we train gets trained properly, because all of it is trained parallelly. But the thing is that in the real world there is no static data. The data in real world is dynamic, so we have to train it again and again. While training again, the model forgets the old data. It rewrites the weights used in the old data, old knowledge, and it focuses on it focuses on new knowledge. Let's see this with an example. Uh, like if we focus on the cyber security frauds which happen, the model trained on the current techniques and current methods to solve those frauds gets outdated. When we update it with the new methods, then the old one gets forgotten by the model, which is prone to more harm to the organization. So remembering the old data is very crucial for the model. So here we bring our method. Currently, three methods are used for it. Full retraining is computationally expensive, wherein we train the old model plus the old data plus the new data completely, which is computationally expensive. Second is fine tuning, wherein we just fine tune the new data. It overrides the old data. And the most efficient method in this is naive replay, wherein they take few parts of the old data and then train on the new data, which then remembers it. But the thing is, naive replays memory efficient. It just randomly takes on the data and takes much of the space for that. So it's impractical for large scale models to use name replay. Then these are the four objectives of our problem statement. First comes retention, that we have to have the stable knowledge of what was there, the old plus new knowledge. Second is generalization. We have to continuously balance all the classes of the data set. Each data sets have multiple classes. We have to balance it. Third is optimization. We have to reduce the overall cost and make it space oriented. And scalability, we have to make this used for large scale models too. And for our demonstration, these are the technical requirements we have used, and we have used GPU, Tesla T4 for training the model. Coming to the main framework that we have created is Lapis Whale. Lapis comes from deep preserved knowledge. Whale means navigation through large information. So what Lapis Whale is? It's a software framework which uses a core algorithm known as SIRM, selective replay utilization mechanism. And what it does, it's basically a name replay but an advanced version of it. It just doesn't takes random data from the old knowledge. It takes those that whose weights are whose weights are reduced. So the whole process goes like this. The first stage is that we monitor which weights are reducing its importance, and those who are reducing its importance are selected from it. For the demonstration, we have used CIFAR 100 data set. It's a data set of photos wherein we have 100,000 photos. So it's one photo is of one class is of 1,000 photos. So there are 100 classes. So the thing is, it takes one photo, one data set, one sample from each class. So it's a class balanced replay. Means the replay is done, but it's class balanced and it's focused on those memory that are prone to lose. So we don't lose the main memory from the old knowledge. And they are the key features that I just said. Replay buffer selective. It chooses those that are required. Knowledge consolidation. It prevents the overwriting of the previously learned knowledge. Resource aware updates, like it reduces the cost means compared to the full retraining or name replace. Obviously less cost because it just focuses on a very niche and specific type of data. Let's move on to the main algorithm that we have. It's a SIRM. SIRM stands for selective replay utilization mechanism, and it is the main working principle and USP of our project. In conventional training, like the transformers are trained on large data sets, and it's not fine tuned. It's fine tuned, but just on the random data from the old knowledge. SIRM chooses specific weights from the old knowledge to train on the new data. Like if we give example of CIFAR 100, which we used for the demo, CIFAR 100 has 100 classes. The training data will take one data set sample from each of the class to train it, and not many samples from one class. That will make that part to remember and the rest of the part to forget. So SIRM improves this process by selectively retraining only a small class balanced fraction of represented past samples, which I just said now. And this covers much of the space. This saves much of the space, and this also preserves the forgetting the prior learning. This is the formula that we used. L series, L new plus L replay, and this part is the formulas expansion. What is does basically in the model? It selects the dataset samples based on the entropy. Entropy in the dataset model is how much they are prone to use and how much they have created impact on the model. Based on cross entropy loss, L new and L replay. L replay is the past ones that are calculated on from the old knowledge, and the new ones that we are going to train. It calculates both of them. This is based on the memory buffer, and memory buffer is the group of all the selected samples from each of the class. So it based on those specific samples, it trains the new data, which reduces loss to a great amount. And lambda is the hyperparameter of the model, which regulates the important and not so important part to remember from the old data. So this is the main for a formula that we are using. We can see the comparison table here that shows currently used method EWC and LWF, which has currently used. These are basically naive replay methods, types of naive replay, and based on 4 parametrics that we see, our serum method is has the maximum average accuracy, and this is trained on many platforms. This is shown on many platforms. This one we have taken it from Google Colab, and the average accuracy of ours is more than the currently used methods, with the forgetting being very less. In the second table, wherein we see overall performance comparison, we can see the average accuracy of naive replay is more than the serum, but the space it takes is hectic. So the forgetting is also low. So our method is good in accuracy, for not forgetting, and the space it takes is very less. We can see here the serum just takes 2% of the memory overhead. The class sample which we have discussed is the memory buffer. It is called the memory overhead. It takes just a 2% of it. So our method uses low space and still remembers the important data from the uh, old knowledge.
Sorry to
This
disturb you,
is
sir. However, we have completed our 9-minute mark. I request
sure,
you to
ma'am,
kindly
sure.
conclude as soon as possible. Thank you.
Sure, sure, man. This is the literature survey. These are the result we have found, and the graphs that we have taken from the Google Colab, and this all shows that our serum performs very well in remembering the old knowledge. The graph shows the performance with all the methods, all the tasks, and we have used 3 different data sets to check this, and this is the best. So here we conclude, and this is the future. So, do you have any questions, ma'am?
Uh, the, how does your framework balance mitigating catastrophic forgetting while maintaining scalability when the number of tasks grows significantly?
So the first thing that I want to say is the method which we are using chooses the knowledge samples based on weights and biases. Naive replay doesn't choose that based on weights. Based on which data is more prone to forget, we choose that data to retrain first, and then the next data whose quantity is more is chosen. And when there is a large scale model, the same method is the same process is used, and based on that the weight of the losing data, we decide using the formula that which one should be remembered more. This works for both small scale or large scale data in the same way.
Okay, Siddharth, fine, nice.
Thank you so much for your presentation, sir.
So thank you, ma'am. Do you have more questions, or should I?
I don't think so. Sir was satisfied with your answer. Thank you so much for your presentation.
Thank you, sure.
Thank you. Now I would like to request our next presenter. Our next presenter is Neha Kriti, presenting a paper on the title Probanza, a stabilized multi-stage LLM evaluation architecture for semantic fidelity in historical manuscripts digitalization. I request you to kindly take over with your presentation.
Hello, ma'am. Is my screen visible?
Yes, ma'am, your screen is visible.
Okay. Good morning, everyone. I am Neha Kriti, and today I'm going to present our work titled Probanza, a stabilized multi-stage LLM evaluation architecture for semantic fidelity in historical manuscript digitization. We'll start with the introduction. Historical manuscript digitization is important for both cultural preservation and digital humanities research. Once manuscripts are digitized reliably, they become more accessible for scholars, educators, archives, and future computational analysis. However, the task is difficult. Because historical documents are rarely clean. They often contain degraded characters, faded ink, inconsistencies, spacing, irregular layouts, and anarchical spelling conventions. These issues make automated transcription and translation much more challenging than modern printed text. Recent work has shown that the large language model can help reconstruct and translate noisy or incomplete text more effectively than traditional approaches in some cases. Most existing work has focused on improving individual pipeline stages such as OCR, quality, post correction, normalization. These are important improvements, but they do not directly tell us whether the final translation still preserves the intended historical meaning. So, the key question for this work is not just whether the output is reliable or fluent, but whether it remains semantically faithful to the archival source. In the broader literature on historical document digitization, OCR engine, token correction, spelling normalization, and layout aware extraction. These have improved pipeline robustness, especially noisy archival material. However, most of these studies have evaluated intermediate outcomes such as character accuracy, word correction rate, or token overlap. That is useful, but it does not fully answer the final research question in the translation pipeline. A document can perform reasonably well at the OCR level and still lose meaning during the downstream normalization or translation. This is why our study focuses on meaning level evaluation rather than only surface level evaluation. To do that, embedding based semantic similarity approach becomes useful because they allow comparison between generated translations and reference translation at the level of contextual meaning, not only exact wording. So the gap addressed is methodological, how to compare LLMs fairly for historical manuscript translation when semantic preservation is the outcome of interest. The dataset used were a Florentine Codex, Book 1 and 7. Florentine Codex is a 16th century historical encyclopedia documenting Nahu society, and it is one of the most important source for studying early Mesoamerican culture and history. We selected this dataset for a strong methodological reason. It provides both first, real degraded historical manuscript images, and second, trusted archival English translated by Anderson and Dybel, which serves as a reference. That combines that combination is especially valuable for this type of work. The manuscript page also exhibit realistic archival challenges such as faded and irregular glyphs, shape inconsistency, and anarchical spelling, which makes evaluation more meaningful than using artificially clean data. The experimental design. The study uses one factor repeated measure design where LLM configuration was the within subject factor. We evaluated three large language models, GPT-5, GPT-4o, and Gemini 3 Flash via API. Each manuscript was processed by all the three models. This means every page served as its own control. That is exactly why we used repeated measures ANOVA in analysis. The purpose of Probanza was to ensure that the comparison across model was fair and controlled measure, and the key parameters kept consistent across all the experiments include pre-processing pipeline, normalization pipe process, translation prompts, temperature setting, embedding computation. The only variable was LLM. The workflow, the fixed pipeline include image enhancement, OCR extraction using Tesseract, contextual correction, historical to modern normalization using LLM. The LLM configuration was GPT-5, GPT-4o, Gemini 3 Flash, and then we calculated cosine similarity for semantic fidelity, and then we run our ANOVA repeated measure ANOVA analysis in SPSS. Our findings says that a one way that Gemini Flash 3 models perform best, and it has a mean of 0.881 and standard deviation of 0.071. And we have found that the cosine similarity scores across model range from 0.601 to 0.957, which includes moderate to strong semantic alignment with archival translation. And Gemini 3 Flash has the highest mean and standard deviation, followed by GPT-5 and GPT-4. We performed Mauchly test of sphericality was not significant, which means that the pairwise difference between all the three models, the variation was same. So the statistic was significant. So the difference observed in their mean is significant enough to report. The discussion and conclusion. The result shows that LLM configuration significantly influences semantic fidelity while translating degraded historical manuscripts. Gemini 3 Flash achieved the highest semantic alignment and the lowest variability and strongest robustness while handling noisy and degraded manuscript. These findings suggest that stabilizing processing alone is not sufficient. The choice of translation model plays a crucial role in preserving the semantic meaning of the historical text. The proposed Robanza framework enables controlled and replicable comparison of LLMs, isolating model level effects with multi-stage document processing pipelines. Overall, this study demonstrates that architecture stabilization combined with careful model selection is essential for reliable historical manuscript digitization and semantic preservation. Thank you so much. The study was funded by DIPR project, AICT, and Seniors Health Project, and under the guidance of Professor Varun Dutt. If any question, I'd like to take it them now.
Thank you so much for your presentation, ma'am. Sir, do we have any questions?
Yeah.
Yes, sir.
What is the role of each stage in your multi-stage evaluation pipeline?
Yes, sir.
And how does each stage contribute to improving semantic fidelity?
So the image enhancement part was there. If there is some faded, we can give like contrasting, we can increase the brightness. So first part was enhancing the sharpness of the text and the pages because faded text were also there. Then the OCR extraction part came where we used Tesseract to make the character visible to machine. And then contextual correction came where we normalize all the scripts, like all the similar words which has similar meanings but are written differently. They were then normalized. You and then we had this historical to same thing, modern contextual correction, and then we moved to LLM configuration. Basically we then gave the entire text and to the transformer. The transformer was sbert, and then we gave before that no, sorry, we did that to calculate the cosine similarity. We then directly gave this to the LLM via API, and we got the text, the final text and the reference we had, and then we calculated cosine similarity between them using sbert. Like we got the tokens using the sbert transformer. And was that clear, sir?
Yes, ma'am. I think that was clear. Actually, sir's network has some issues because right now he's not here with us.
Okay.
But thank you so much for your answer and your presentation.
Thank
Now,
you,
I
sir.
would like to call upon our next presenter. Meanwhile, sir joins us again. I would like to call upon our next presenter. Our next presenter is Fatima Batul, presenting a paper on the title Shaz, a digital intervention for psychosocial skills development and behavior training of autistic children. I request you, ma'am, to kindly take over with your presentation, please. Ms. Fatima.
Hello,
Yes.
am I audible?
Ma'am, you're audible. However, the volume is little less. 1 second. Okay, okay. My apologies. We can hear you. Yes.
Is it clear now?
Yes, ma'am, we can hear you. I just request you to kindly start over with your presentation. Meanwhile, our session chair will just join us.
Is my screen visible?
Yes, it is.
Okay. Hello everyone, I'm Fatma Batul from National University of Science and Technology, Pakistan. And on the behalf of all the authors, I'll be presenting a research work titled SHAS, a digital intervention for psychosocial skills development and behavior training of autistic children.
Sorry to disturb you, ma'am. Could you please switch your mic on again? There's one slight disturbance. Slight. The mic has some slight disturbance.
Hello.
Okay, this still there. However, I request you to kindly continue.
Am I audible?
Yes, ma'am. Now you're audible.
Is my screen
Please.
visible?
Yes, yes, your screen is visible. Please continue with the presentation now.
Okay.
Thank you.
So, title of our work is SHAS, a digital intervention for psychosocial skills development and behavior training of autistic children. This is the outline of our presentation. So, this in this era of technology, differently abled users uh, have limited to no access to digital devices on equal terms. And according to stats, around 1.3 billion people have some sort of significant disability globally. That is 16% of the world population. And out of these, 240 million are children. Besides this physical impairment, there are some disabilities that are not significantly apparent, and these account for 70 to 80% of all disabilities. Autism, a neurological disorder, is one of it. Globally, 75 million people have autism, and in Pakistan, around 350,000 children suffer from it. According to Diagnostic and Statistical Manual of Mental Disorders, the most common symptoms of autism include social communication difficulties, emotion and joint attention deficiency, sensitivity to changes and simulations. And if we talk about the psychosocial skills, these are the life skills that allow an individual to interact effectively with others. And generally, autistic children lack these skills that affect their daily functioning. So there exist multiple systems that are designed particularly for autistic children to help them improve their developmental skills, including computer-based games, mobile and AR-based apps. Here we will be discussing the most relevant reviewed systems. So these systems are either targeting the cognitive, motor skills or social communication, emotion, or some basic skills of autistic children. And the age group that was considered for these all systems was generally 5 to 12 years. And the sample size uh, the chosen sample size vary based on the type of the study. For example, for the studies involving only autistic children, the sample size was very small, ranging from 3 to 19. However, for comparative studies, the sample size was good. However, the sampling distribution was uneven. So these systems are just targeting single skills and they are designed considering the autistic children of from high to medium functioning, and also that either there was no testing done or the testing was done in a very controlled environment. So these systems have overlooked on the integration of psychosocial skills. So there is the need of a multimodal app that will not only be a source of fun, but will also provide a support for autistic children to help them improve their psychosocial skills. So we set our objectives to understand the autistic children, to design and develop apps based on their preferences, and to assess and evaluate the designed app. So for sampling the participants, we use convenient sampling, and our final sample included 25 primary participants, the autistic children with different severity level of disorder, and 3 secondary participants. And for research design, we use mixed method approach that combines both qualitative and quantitative measures. Our qualitative measures included one-to-one semi-structured interviews with secondary participants, and the quantitative measures included questionnaires, the app data, and behavior observation during testing. For product designing, we used user-centered design approach, and the features and graphics of the app were designed based on the preferences of the user. The app was called Shiaz, and it was named so because it is an Arabic word which means exceptional or unique, and it was named so based on the characteristics of the autistic children. It this app integrates multiple input and output modalities such as audio, visuals, and such. And it was designed using MIT App Inventor, that is a visual programming platform. And the key features of the app included big buttons, colorful visuals, and audio and animation to make it visually appealing for children. The architecture was based on the client server with like cloud database. So the user interacts with the app, that is the front end layer, and any action on the front end layer sends the request to the back end layer where the core logic exists. It processes the input and displays the output back to the screen. Meanwhile, the data layer manages the data retrieval and storage. So let's quickly have a look on the modules of the app. So it has Catch the Cat that was designed to target the fine motor skills, Flip the Card for cognitive skills, Emotion World to let them understand, interpret, and imitate emotions, ABC World for language and vocabulary skills development, Letter Select for behavioral and regulation, emotion regulation, and Feeling Corner to let them interpret their emotions. So, before testing, in order to contextualize the theory and establish a baseline requirement, the secondary participants filled out few questionnaires along with the interviews. So the results highlighted the barriers of autism in Pakistan, the challenges faced by autistic children, and the strategies the caretakers used in dealing with them. And they suggested to have a simple and clean UI with clear audio and textual instructions. So the app testing was done in a natural environment to let them interact with the app naturally, and the sessions were done individually and recorded as well for behavior observation of users. So first, the prototype of app was tested for 15 days, and after 3 days, the actual app was tested, and it lasted for like 5 weeks. And the data from the app was collected across 4 observations. And in our app data, we had moderator variables like age, gender, and severity level of autism. And the observed variables were actually the scores from the modules. Later on, we used vector analysis to map those observed variables to construct new latent variables, and we name them motor, psychological, social, emotional, and behavioral scores. So then the app data was evaluated to see how the user performance changed over time. So this graph is representing the average scores of each module across the observation. On x-axis we have observation number, and on y-axis we have performance scores. So here we need to observe that for flip the card, we have a decreasing curve. For other, we have kind of increasing. But the reason for this decreasing curve is because its measure was time. So decrease in time with across observations actually means that they have taken less time to complete the task across the observation. That actually is an improvement. The second thing to observe here is a abrupt change in the scores of observation 1 and observation 2, and that was because of we actually playing continuous intervention. However, due to some unforeseen circumstances, there was a delay in observation 1 and observation 2 that actually causes an abrupt change in the scores of observation 1 and observation 2, and it can be seen throughout the result. So overall, for all the modules across observation, the performance of the users have improved. Also, the latent variables were mapped also to see their like how the performance changed across how the latent variable scores change over time. So it also shows an improvement with time. However, this orange one, the psychological score, is again showing the decreasing curve. That is again due to the reason that it has the highest weightage for flip the cards with was time. So overall, the result of the data showed an improvement over time from observation 1 to observation 4. Besides these, the behavior of users was behavior of user were also recorded using telesampling in 2 samples to observe their engagement. So its result shows that with time, there was an increase in the frequency of the positive behavior and decrease in the frequency of the negative behavior, implying a good engagement of app or a good engagement of users with app across the observation. After testing, system usability scale and app impact quality evaluation questionnaires were filled by the key informants. The usability score turned out to be 89.16. That showed good usability, and the rating score was 4.27. Besides these, the key informants also suggested few features that they want to see in the future version of the app, and those included basic mathematical concepts, complex emotions, sentence building, and storytelling.
Ma'am, I request you to kindly conclude as soon as possible, please. We have completed the 9-1 mark.
Okay. So beside this, as the results have shown improvement over in the skills score over time, and the app usability and quality was good, there are some limitations that or sample size were not as expected due to lack of time and resources. We just evaluated it for like 7 weeks. So in future, we intend to test the app with larger and diverse group for a longer period of time. In addition, we will add new features based on the recommendation of the secondary participants. These are the references that I have referred during study, and that's it. Thank you. If you have any question, you can ask. Your suggestions will be highly appreciated.
Thank you so much for your presentation, ma'am. One second. Sir, do we have any questions?
Uh, how do you address concern related to screen dependency, data privacy, and parental involvement while using SARS as a digital intervention?
Can you please repeat it? I'll note it down and I'll answer you one by one. Can you please repeat your question, sir? No.
Once again, I am repeating. What
Screen dependency and which you asked, I just forgot it.
how do you address a concern related to screen dependency, data privacy, and parental involvement while using SARS as a digital intervention?
So, screen dependency, we just like allowed them to use the app just for a specific period of time, because it was the concern there that the screen time was the main issue that was triggering their symptoms again and again. So we just tried to keep that as short as possible. We can actually not reduce, like cut out the screen time of for autistic children. So we just had like like one session lasted for only 15 to 16 minutes. That's it. And data for privacy, we use Firebase real big data, Firebase real-time database that allows for secure data storage, and also the app data was anonymized before used anywhere for analysis.
Recording in progress.
Is it what you were asking?
Okay, Fatima. Well,
Is it what you were asking?
Yes, ma'am, sir is satisfied with the answer.
next one, please.
Okay, sir. Thank you so much for your presentation, ma'am. I would like to call upon our next presenter. Our next presenter is Omkar Yende, presenting a paper on the title Stock Price Forecasting Using Time Domain Filtering and Deep Learning. Sir, I request you to kindly take over with your presentation, please.
Thank you so much, Prashi, for giving me this opportunity. Should I share the screen?
Yes, please, sir.
Thank you so much. All right. I hope my screen is presentable to each
Yes,
and
sir.
every. Thank you
Yes,
so
sir.
much. So, good afternoon, everyone. Good afternoon, sir. So the topic which we are going to present today is the stock forecasting using time domain filtering and deep learning. So this is going to be a novel hybrid framework integrating causal filtering and STFT and LSTM. So for the causal filtering, we have used the Savitsky-Golay filter and Kalman filter. The STFT refers over here is the short-term Fourier transform, which is a shorter version of fast-term Fourier transform, and the LSTM, which is the long short-term memory model, which is the deep learning model under RNN. The research was conducted at Ramdev Baba University, Nagpur, Maharashtra, India. So let's move forward. So let's try to understand what exactly the problem over here is. So the problem which the stock market basically has that it's completely noisy, non-linear, and non-stationary, making it very inaccurate for price forecasting and is a persistent challenge over here. So what's our approach over here? We tried to build a novel hybrid pipeline model combining Savitsky-Golay filter and Kalman filter. This basically are going to be the two different studies and two different pipelines which are being conducted in the further slides. Then we had tried to apply the short-term Fourier transform over here, then the LSTM model for deep learning. So what are the end results? So the end results which we achieved over here with the MAPE, which is the mean absolute percentage error, the improvement is of 12 to 11 to 12% from the best baseline model, which was the STFT, including the LSTM across the three indexes, one index and two equities. One is going to be the Nifty 50, one is the Reliance, and one is the HDFC datasets over here. So the problem statement. Let's try to understand that why forecasting is so difficult. The first thing is the high noise. The market has multiple microstructures which depletes the quality of the model in order to understand the signals, hence making it difficult to forecast further. The next thing was going to be the non-stationarity of the market. So market has multiple inefficiencies which need to be tweaked out over here. The tweaking out over here are the statistical properties. The statistical properties change and evolves multiple times. In 1998, it was for the first time uh, when the frequency thing was being involved into the market by the Medallion hedge fund under the Jim Simons in 1988. He tried to tweak that frequency uh, domain by involving his hedge fund into it and earned billions of dollars into it. The next thing was the nonlinear dynamics. The price movement are driven by complex interdependent macro and micro factors. There could be anything: CPI, dollar index, crude oil, the current war state scenario, multiple factors involved in driving the market higher or lower. Next thing is going to be the look ahead bias. What we observed over here is that a data leakage problem. What basically happens is that the filters work on the centered window pattern or the sliding window pattern. It has a high probability that the data from the future get leaks into the training set, which makes the prediction of forecasting unreliable. So what's the motivation over here? The motivation is not only that the particular project should remain only into the finance domain. The project should also have a cross-boundary domain such as the logistic, medical, and even into the energy markets. Okay, so let's try to understand what was the research gap. Despite decades of research, deep learning model for stock forecasting share critical structural deficiencies. So what were the key structural deficiencies which we pointed out? There was no causal filtering, which means that the filtering which was being done was either non-causal or completely on the basis of the average or the different type of statistical models. The second thing was there was a missing integration of the time and the frequency domain. One is the time, which is time frequency domain into it. The third thing which we sought is that there isn't a unified hybrid framework which involve filtering, spectral analysis, and deep learning into it. So this all three are the baseline models which we sorted out from the references which we have taken. One is the vanilla LSTM, where it's a plain LSTM model. Second is the FFT involvement into it, and third is the STFT. So basically try to understanding that what's the difference between FFT LSTM and STFT LSTM. In the FFT LSTM, we were able to see that it was a complete global FFT, which means that if we are having T1 to T100, the FFT was being applied over the complete 100 numbers of prices into it, which makes the small signals, which is the small microstructures, to completely denoising it, which isn't possible for us to analyze it on a micro scale. Then we tried to shift over the sliding window pattern, which is STFT, over which we were able to track down the microstructures of the market, hence improving the efficiency of a model to learn on a higher data sets. Our contributions. So our contribution first is building a complete causal pre-processing pipeline. The pre-processing pipeline has strict causality, no future data leakage at any stage, enabling real-time deployment. While testing, what we had observed that the data used to seeps into the training set. Hence, we tried to tweak our code into such sense that the data remains completely intact for the training set without using any future prospects into it. Second is the filter comparison study, then enabling a hybrid model architecture, then achieving a benchmark of 11 to 12%. Okay, so now let's try to understand the system architecture, that how the system architecture is going to work. The first is going to be the raw input, which is going to be the prices, the stock prices or the index prices. It could be anything, even the energy prices, multiple domains. Next is going to be the pre-processing stage, where we are going to actually try to concise that or limit that into a certain set in order to feed into the further procedure, which is the causal filtering. The next is going to be the STFT, which is the short-term Fourier transform. Then is going to be the feature fusion into the LSTM model. Everything would be combined and put into the LSTM model. Each module is designed to causally consistent only on past and present observation. Information, any computation ensure the system is deployable in live trading environment without look-ahead bias. If I want to refer that what a causal signal refers to is the output value will be only dependent upon the present and the past value. No future look-ahead bias need to be over here into a causal system. All right. So these are basically the data set and the experimental setup which we have set up over here. The methodology. Now let's try to understand that what Savitsky-Golay filter, Kalman filter over here basically states to us. So the Savitsky-Golay filter is a smoothed technique that fits a polynomial over a sliding window of past data point. It removes noise while preserving the original shape and trend of the signal. In our work, we use causal version, meaning only past data is used, ensuring no future information leakage. Moving towards the Kalman filter, the Kalman filter is a over here, it's a recursive probabilistic estimator that determines that next state and it corrects it using the new observation. Means that the weights are being updated over here in order to predict the new state. It adaptively balances the prediction and measurement based on the uncertainty, making it effective for dynamic and noisy environments like the financial markets. STFT has a two output. One is going to be the amplitude and one is going to be the phase. In LSTM, it's a time domain plus the frequency domain features vectors were are being added into the stack LSTM layer for sequential price prediction. So LSTM over here basically tried to find the temporal dependencies. It basically tried to understand what are the patterns and how it could be used in order to predict or forecast the future markets. So these are the experimental results. The training time was for the next 30 days. The data set which was being taken, it was for the more than, I guess we started with 2015 and now it's 2026. So 11 years of data is being fed into the model, which is being fetched from the Yahoo Finance, and everything is being compiled on Google Colab. So on Nifty, we gained efficiency, a MAPE improvement of 13% from the best baseline model, which is the STFT. I'm sorry. And in the HDFC Bank, we gained a MAPE improvement of 12%. So this is the simulation and the extra thing. Prashi ma'am, how much time do I am left with?
So we have just crossed the 9-minute mark.
Okay, we just
So
crossed.
I would
Okay, so
request you to
I have 6 minutes. Okay, sure.
No, we have crossed the 9-minute mark.
All right. So,
So
okay.
yes.
Okay, let's try to compile this very quick. So basically, this is the representation of the frequency cycle, which I have displayed over here. Uh, the lowest frequency refers to that the highest time frame is being covered over there, which is the yellow line. And the yellow line, we were able to see it is being plotted for the 90 days. In the STFT, what we have discovered is that we got two things. One is the amplitude and one is the phase. The amplitude tells that how strong the trend is, and phase tells us that where actually are we in the trend. So the red dots, they are at the top. So LSTM earlier was just only trading on the prices. Now it will try to understand that where exactly in the frequency cycle through the phase, that where exactly where are we standing. If we are at the top, the strength is strong, what is the result that the LSTM will try to predict? The LSTM will try to predict that the next stage would be that there would be a downfall into this particular cycle, because every cycle is being plotted on the basis of a sine wave. X of t is equal to a multiplied by sine 2 pi f t plus phi. So this is something which I want to mention over here. And these are the references which we have taken. And currently our project is into the research paper stage. And that's all from my side. Thank you so much. The panel is open for discussion.
Yeah, uh, I have one questions to you.
Sure, sir.
Financial data is highly noisy and non-stationary.
Correct, sir.
How does your model handle sudden market shocks or anomalies? And how robust it is across different market conditions?
Correct, sir. So basically, any crash or any burst, it basically has some past historical context to it. So the model is being trained on a diverse range of 10 to 15 years. And as I have stated, that this is an LSTM model. An LSTM model has a tendency to remember past thing, because the vanishing gradient problem is being completely sorted out in this particular thing. So if we are standing at today, US-Iran conflict. So even if the market crashes, the model remembers that how it crashed in 2008, how it crashed in dot-com crisis, how it crashed in Corona crisis. So understanding that frequency, the amplitude and the phase of that particular stage, the market structure, LSTM will try to prepare a pattern into its memory, the cell states and the memory, and try to figure it out that how and to which extent it could crash.
Okay, well,
Sure, sir. So is there anything more?
no, not more questions.
Thank you so
Thank,
much for your
thank you so much,
presentation.
Prashi and sir, for giving me this opportunity.
Thank you so much, sir. Thank you so much for your presentation. I would like to call upon our last presenter for the session, Vai Ramadevi, an author, is presenting a paper on the title His Views, Linear Time, Hierarchical State Space Fusion for Histopathology Classification. I request you, the co-author, Ms. Panigrini Shrikant, to kindly take over with the presentation, please.
Yes, ma'am. Is it audible?
Oh, sorry. Okay. Yes, yes.
Is it audible, ma'am?
Yes, they are audible.
One minute, ma'am. So I will share that my screen. Hello. Is it visible, ma'am?
Yes, it is loading. 1 second.
Is it visible? My presentation?
Just give me 1 second, sir. Right now we can't see it, but yes, yes, now it's visible, sir.
No, okay. Okay. So good afternoon to one and all. This is Shrikant, and my professor is Vai Ramadevi, ma'am, and one more author is Devanshu. And coming to my article is that is a HFuse, that is a linear time hierarchical state space fusion model for the hypothetical classification. This is for medical in the completely medical domain. We are proceeding with pathology based images. So here we are operating as different kinds of state space models. We are proceeding with the different kinds of state space models with respect to and as a state of art based models. After that, we are comparing. We'll come up with pathology based. We cross-checked that different fusion strategies also. So that we construct that linear time we can possible to reducing of the time, so that we have proceed for linear time hierarchical state space fusion for hypothetical classification. So now move on. I'll come into complete outline of my presentation, that is introduction part, as well as motivation of my entire presentation, and come into my work. So the next one, I'll give the clarity about regarding that proposed architecture part and experimental setup and results, and finally conclusion. So now move on. So this is a complete overview of introduction and clinical motivation. So main this pathology based analysis, that is one of the standard for cancer diagnosis. So what are the main important challenges we are observing and the previous existing articles and current work? So the complex of multi-scale tissues, the structures is very tough to handle. That is one of the challenge, and high intra-class variability. So the stable morphology and differentiations and large scale high resolution of the data. So in this, these are the main challenges we are facing. The choosing of the hypo histopathology based images, especially pathology based images. And some, there is a pathology based images also, the tissues or the structures there is a different to identify. The complex part is very tough to handle that. So what are the limitations now? So the see, when are choosing of convolutional neural networks, we got that we're capturing some kind of local level features, and long that dependence is very tough to get capturing. And coming to transformers, we capture that long level global level features as well as we're getting that high computational cost. So that is the main motto. We'll proceed it to state-space models with respect to you're applying multi-scale feature fusion. So now coming to main objective of this work, they are developed as linear time hierarchical state space fusion. The framework that efficiently integrates multi-scale representation with global context modeling. Here, integrating two kinds of features. One is a global context features that is comes under state space model and integrated with multi-scale representation, so that we can possible to accurately classifying the histopathology based images. So, and this is a exact motivation from as an introduction as well as motivation part and to handling of the faculty based images. So now move on. This is a overview of entire the architecture part. The first one we are considered as a faculty based images. So after that, this complete architecture we need to follow one of the model that is called as Mamba. So the Mamba is mainly the main motto is of Mamba. We can possible to handling state space strategy, including that Mamba. So here, observe now, this is the SS conventional state-based model. In this context, we are proceed with consolidated input data with respect to conventional block as well as a state spatial branch, so that when you're comparing the combination of these two, they have possible to building that is called as SS conventional state space Mamba. We are considering as a stage one after getting of patch embeddings. Then after that, again we can possible to proceed at stage 1, stage 2, stage 3, stage 4, so that each stage wise we are capturing different categories of features. Those features that is comes under low level features, medium level features, high level features, and deep level features. So that so these features we can possible to handle via hierarchical feature fusion block. So in this block, we can proceed it. Initially, we proceeded layer normalization. After that, we can possible to apply. Very importantly, we are applied depth-wise convolution block. After that, token mixture that is a comes under Mamba. After that, we are adding with residual block, and we can after that we are applying as feed forward network. In this context, we are considered linear. We are applying as activation function is a GLO and dropout, so that we need to construct hierarchical feature fusion block. And so here, what happened is a state space exactly the scanning of the inputs. 2D there are different procedures for scanning of procedures is there. We are proceeding with 2D selective scanning procedure, that is SS2D procedure. So based on this procedure, we're capturing very effective and very optimal features. We are capturing very optimal features from each block wise as well as each stage wise. So each stage wise. So this is the exact motive will constructing of my proposed architecture that is called HISS fuse. So this is overview, and coming to observe now each stage wise, and we'll do the data about regarding that. Coming to feature extraction. So in this slide, you're focusing. First one is a positional encoding block. That is we can capturing that embeddings. After that, we have cut into the hierarchical. That is a backbone. This comes under MedMamba. Of so here we have captured that different categories of features, that is a F1, F2, F3, F4. low level features, medium level features, high level features, and deep level features. So this is the main motto we'll proceed it as a using choosing of the backbone. As this before choosing of the backbone, we are applying the state of art models based on the results only we are picking as Madbomba as a backbone. After that, we have proceeded with SS convention block also. That is very helpful for that the capturing of the very optimal features. So that now after checking that fusion and prediction blocks, so hierarchical state space fusion here they're captured with multi-scale features from from stage 1 to stage 2. They're capturing from stage 1 to stage 2 and stage 2 to stage 3 and stage 2 to stage 4. Likewise, we can capture it at global level and very efficient feature. After that, these features they fed into the multi-level feature fusion, then fed into the linear block that is called linear block linear block so that we can proceed it so that you can proceed state space modeling. So this is exact procedure for the getting that predicted. So after that the finally we are including that one of the heading that's called classification block. So this is a procedure we are getting that hierarchical state space fusion and multi-level state space fusion. This part will be integrated just a minute. So now this is the scenario will be proceeded under the architecture, and these are the overview points. And and coming to this is a workflow I proceeded. So first one is input hypo histopathology based images and pathology based images. So here we are considered as 2D based images as well as some we are expected 3D, but we are not included in this article. So after that, we are capturing that patch embodies that is a very starting stage. After that, we are fed into the hierarchical backbone that is a Medmamba. We capturing each stage-wise features. After capturing that those features, they fed into the SS conventional stage-based block. So after so that we are capturing we can call as G1 G2. After applying that from backbone the features just have to fed into the SSN that is a state space with convention block, so that we got that G1 G2 G3 G4. Then again we applied as hierarchical state space fusion, so that we got that Z1 Z2 Z3. So these features fed into the transformer block, and so that we got that final predicted values. So this is a procedure you can procedure for capturing very in between that from as a backbone what we're getting that low level features, and after that we have to set into the convention and state placement model, so that we're capturing very
I'm sorry to disturb you, sir.
yeah
However, we are crossing the 9-minute mark. I request you to
yeah
kindly conclude the presentation.
yeah. So so now after that, so this is entire overview of workflow as well as my architecture part. So now my experimental setup have proceeded with these are the path amongst one of the benchmark data set. We are proceeding with 9 issues. We are applying the pre-processing, and we are choosing optimization. We are proceeding with the training setup. We are considered GPUs RTX A400 GPU, and this is the value of total distributions of my classes, that is tissues of exact. So total 74,000 of samples you are consolidated. This is your input data. After that, this is a state of art with respect to applying as proportion model. Each class wise we got that results, that is a precision, recall, and F1 score. And this is overall accuracy, we got that 97% with checking of entire the experimentation with respect to proposal model. And coming to these are the state of art with respect to path monastery data set. So we are applying as CNN based models and transformer based models as well as state based models. So the CNN, that is CNN pre-trained models, ResNet and ResNet 50 and DenseNet 121, efficient B0 and other models also we are concentrated. But here entire the things we are included article as well as transformers that comes under bit vision transformers and DITE that is comes under Meta and Dino that is a very recent model and was and state one of the MedBit that is one of the best article here that is also here prosecuted. And coming to a proposed model is getting that very good accuracy with respect to existing models. And so now coming to ablation part, we are proceeding with the backbone and first fusion level and second fusion level and third fusion level, and that is a comes under full model. So this is so the accuracy gain is when I proceed with hierarchical fusion, we proceed 4.5% is. So after that, how much computation power with comparing CNN, that is a convolution models and transformer based models and state based models with respect to the efficiency is how much will be with crossing with number of parameters and latency and finally you're crossing with accuracy also. So this is about entire the computational efficiency and computational power of existing and how much cost also. And coming to conclusion, so we proceed with we propose one of the architecture that is this architecture. So this linear time hierarchical state space fusion framework with respect to histopathology classification, the combinations with respect to conventional and state space blocks. That is, we're capturing local features and global features, so that integrated with hierarchical feature fusion, so that we got that progressive based multi-scale fusion. They effectively features integration across the depth level. We achieve the 97% accuracy existing with the existing works, and AUC curve value also with getting that 99.7 on that one of the benchmark that is a path MNST. So that this is the strong efficiency part. And coming to my in future direction, I have working on it foundation models as well as we need to working on it regarding 3D images with respect to same thing, the same proposed model. We can proceed it with segmentation task as well as a detection task. We can possible to apply multi models also, and we can possible to deploy and real-time clinical models also with respect to histopathology based images. And these are the references with respect to deep learning and vision models and medical images based models. Most of the purpose like as a CVPR, ICML, and McCoy. In the so most probably we are utilizing most of the articles from McCoy and very famous conference. That is the reason we are concentrated and that is a we are utilizing at the state of artworks point of view. And so these are so that's it. So this is and thank you. And any questions, please? Yeah.
Yeah, I have a question.
Yeah.
How
Yes.
does your model perform across different data sets or standing variations?
Yes, sir. So that is the reason we proceeded with respect to convolutional neural networks as well as transformers, including state-based models. After cross-checking state-based models, so it's giving the better results. So that we fed into the feature fusion that is called a multi-level feature fusion as well as hierarchical feature fusion. So that integrated into this comes under via linear pattern. That is the exact procedure or we are fed into the as a backbone. So that, and one more key point is we are trying to include that we can possible to checking number of parameters as well as how much computational cost and computational power and with respect to performance. So these are the points we are checking from existing works and current work.
Okay, well.
Yes, sir.
Okay,
Yes.
Srikant.
Yeah.
Hi, Srikant. I
Yeah,
have one
yeah.
question. I have one question, right? You have shown in the transformer, you have done the patch embedding with a like split of 4. So why did you do that? I mean, just empirically did you do, or by any chance you have done this thing?
Yes, sir. Yes, sir. I agree regarding. So actually, what happened is we have proceeded with and convolutional neural networks and what are the pre-trained models and CNN based models with respect to we are applied the same strategy with respect to multi-level feature fusion as well as transformers. What are the transformers? Just observe now, sir. This is the state of art models. We are including few of models only in that article. Included all the models. And coming to point, CNN based models we are considered ResNet, DenseNet, EfficientNet. Efficient net region,
No. Shrikant, my question is again the transformers based I mean the patch embedding that you have done in your I mean for your model you have
Mm-hmm.
taken as a split of four. So if you can go to that slide that you have shown a H by W, C by W,
Yes, sir.
width
Yes,
by
sir.
W,
Yes, yes,
width
sir.
by
Yes, sir.
four.
Yes, yes, sir.
By four you have taken. I mean by empirically you have taken or
No, no. After pre-processing, after the pre-processing, because of the input
no?
size is
Why did you choose four? I mean the number four. Why did you choose that number? I mean.
uh,
So
why do
it is
because of
broken into four patches. Your feature activations are broken into four patches.
yes, 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 sir. Yes, sir.
So why four? I mean, why four patches?
Because of your proceeding regarding that four levels of stages, like as low level features, we are capturing low level features and medium level features and high level features, so that we proceed with deep level features.
Okay. So you have fused the uh, two branches with the
Yes,
spatial.
yes,
I'm using the spatial pixels. If I
correct.
am wrong, yes.
Correct, sir. Correct, correct, correct.
So that is the state space, I mean, fusion,
Yes,
right? So
yes,
multiple channels, I mean, multiple channels are fusing into single space, I mean.
correct, 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 sir. Correct, sir. Correct,
Okay. Okay. From my side, it's fine. Okay.
correct, sir.
It's a good work, actually. Yeah.
Yes, yeah.
Very good.
Thank you. Thank you so much, sir. Thank you so much, sir.
Thank you so much for your presentation, sir. With this, we come to the end of our session.
Sir, sorry for interruption. And my professor also joined just now. And thank you for joining my professor. And thank you for reviewers also. And thank you for organized team also. Thank you. Thank you so much.
Thank you so much, sir. So with this, we conclude our session. I sincerely thank all our authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 11th version and all the previous 10 versions of this conference. We will be happy to have you in the 12th version in 2027. All the presenters would be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICTIS 2026. I would also like to thank our session chair. Sir, thank you so much for joining us today, Dr. Rao. Sir, this is a token of appreciation from our team. Any last words before we conclude our session, sir?
Good evening, everyone. As we conclude this session at the 11th International Conference on ICTIS, I would like to sincerely thank all the presenters for their insightful and well-prepared contributions. The diversity of topics and innovative approaches shared today truly reflect the rapid advancement in the field of ICT. I also appreciate the active participations of all the presenters. It is inspiring to see such enthusiasm and quality of work, especially from emerging fields. Thank you. Thank you very much.
Thank you so much, sir. Now, I just request all of you all to kindly switch on to your cameras so that we can have a quick snapshot of this virtual session we just attended. Requesting all our participants, all our presenters to kindly switch on to your cameras, please, so that we can have a quick snapshot of this virtual session. Requesting all to please switch on your cameras. I request all of you all to please switch on to your cameras for a quick snapshot. Thank you so much. Stay safe, take care. We'll meet in the next version, the 12th version, 2027. Thank you so much for joining in. Thank you.